Greetings, my name is Professor Duke Orata. We are continuing our lectures on steady flow and jet propulsion. Today we want to obtain the value for mass flow rate per unit area. Now, remember that we had gotten this earlier expression, mass flow rate per unit area. We had gotten the expression where we had 2n, 1 minus n, P1 or V1, into P2, V2, n plus 1 over n minus P2, not V2, P1, two over n. All this expression was under square root. So to remove the square root, so that our lives are easy, remove the square root, we have m over a2 squared. We have moved the square root, so we square this particular quantity. So we'll have that as equals to 2n minus n, P1 over V1, into P2, P1. I don't know why I like talking about these. This is n plus 1 over n, minus P2 over P1, 2 over n, now we have squared, so we have removed the square root. And then we also gotten the expression at the throat. We saw the pressure, P2. The pressure P2, which you can also call the throat pressure, also referred to as throat pressure. So let's call that PT, or as critical pressure. PC. So that ratio which we got, the critical pressure ratio, that is P2 over P1, or now we can call it PT over P1 or PC over P1. P2 over P1, we can also be expressed as throat pressure over P1 or critical pressure over P1. Remember from our earlier lectures, and I encourage you to go through our lectures systematically because we have worked on these things comprehensively in those lectures. Can now be, was found to be 2n over 1 plus 1 minus n, 2 over 1 minus n plus n minus 1. You got that expression there. That's the ratio. That's the critical pressure ratio. P2 over P1. Got the expression 2n, 1 plus 1, n over n minus. Remember, n is the entropic index of expansion, don't forget. Got that in the polytropic equation, and we say that for vapor the value will probably be 1.13, and for in the superheat region it would be probably 1.3. So this is the critical pressure ratio, so we can call that the critical pressure ratio. Now, we can obtain the value for the mass flow per unit area by combining equations 1 and equation 2. So to obtain the value, of m over a2, that is the mass flow per unit area, mass flow per unit area, we combine 1 and 2. And that's very straightforward. So what do we do? Combining 1 and 2 is very easy. So we have, let's call that 1. That's the one we are interested in. Combining 1 and 2, so we have m, therefore, don't need that anymore. You can combine the two. We'll have m over a2 squared is equals to 2n over 1 minus n P1 V1, and of course you insert the value of this critical pressure ratio P2 over P1 in place there, so we have 2n over 1 plus n, n over n minus 1 raised to power n plus 1 over n. We have simply put in the value here for P2 over P1, we have substituted there, and that would be also 2n over 1 plus n, n over n minus 1 into 2 over n. So we are getting there. We will of course use the identity. We'll use the identity, don't forget, of the indices, where if we have x to the raised to power m, and then again multiplied n times, we'll have that as x the m n. So we'll use that particular identity to solve these indices there. So let's just do that. So using that particular identity, we now have m over a2 squared is equal to 2n over 1 minus n into P1 over V1 into 2n over 1 plus n into n over n minus 1 times n plus 1 over n minus 2n over 1 plus n into n over n minus 1 times 2 over n. And clearly you see that things are becoming a lot easier. The n's will cancel. So we end up with a more refined expression, m over a2 squared as being equal to 2n 1 minus n into P1 V1 into 2n over 1 plus n, n plus 1 over n minus 1 minus 2n over 1 plus n 2 over n minus 1. So we just used that identity involving exponents, and so this looks much better now. Things are becoming a lot easier. All you have to do is just to do it patiently so that you don't get mixed up. Now, if you look at it carefully, you notice that this is 2n 1 minus n. So if you multiply by a negative number, then we'll have 2n 1 plus n. So just note that 2n over 1 minus n is equals to minus. You have that, if you multiply by a negative sign, minus 1 plus n. If you multiply by negative sign, then that quantity there will be plus, which, if you rearrange that clearly, you see is 2n n plus 1. 1 plus n is n plus 1. There's no difference between the two, so don't get confused over that. So we can recast this expression there. So we can recasting this. So you're applying it in that expression. Therefore, we have m over that's minus that is that m over 2a2 squared is equal to, we take the minus of that, So we'll have minus 2n n plus 1. Take the minus sign for that particular quantity. Minus 2n plus 1 P1 over V1 into 2n 1 plus n into n plus 1 over n minus 1 minus 2n 1 plus n 2 over n minus 1. So we can insert this quantity. We can rearrange this particular quantity here and insert it here and insert it there. So we will have simply m over a2 squared is equal to minus p1 over v1 into 2n over 1 plus n multiplied by 2n over 1 plus n plus 1 over n minus 1. Remember, we said 1 plus n is just n plus 1. So either way, it's just to make our quantities uniform for simplicity of calculation. I've just recast it as 1 plus n. And so minus, again, 2n over 1 plus n times 2n over 1 plus n raised to the power 2 over n minus 1. Like we have already said, when we multiply these quantities, we add the indices. We are just using the identity xm times x to the power n. That will be xm plus n. So that's what will happen here. Remember this raised to power 1, that's raised to n plus 1, and so you'll add 1 plus that, then this raised to power 1, you'll add to that, using that identity which you have indicated there. So this raised to power 1, so you'll add it to that, this raised to power 1, you'll add that next to that. So let's see what comes out. So if you use that identity, then m over a2 squared will be minus p1 v1 into 2n over n plus 1, n 1 plus n, to 1 plus n plus 1 over n minus 1 minus 2n over 1 plus n into 1 plus 2 over n minus 1. So let's solve this quantity. So that becomes m over a2 squared will be minus p1 over v1 into, take the LCM, n minus 1, so it will be 2n, 1 plus n, LCM, n minus 1, it will be n minus 1 plus n plus 1. Very simple. Again, for this particular one, will be 2n over 1 plus n, LCM is n minus 1, will be n minus 1 plus 2. So if we simplify these quantities, just handle them like any simple arithmetic quantities involving fractions. So that becomes minus p1 m over a2 squared becomes minus p1 over v1 into, we have minus 1 will cancel plus 1, so we have 2n, we have 2n over 1 plus n into 2n over n minus 1. And the other quantity there, when we simplify again, will be 1 plus n. Again, that will be n minus 1 plus 2, so will be n plus 1 over n minus 1. So we are getting there. We are getting there systematically. Now, if we divide by this quantity, dividing by 2n over 1 plus n, the power n plus 1, n minus 1. If we divide that expression, we'll have m over a2 squared as equal to minus p1 v1 into 2n over 1, and let's put it down a bit, m over a2 squared will be equal to minus p1 v1 into 2n over 1 plus n, 2n over n minus 1, divided by 2n, over 1 plus n raised to the power n plus 1 over n minus 1 minus 1. Remember, we've simply divided these quantities. We have divided them by 2n over 1 plus n. So we have gotten that that's 1, and of course divided by that. And you remember that using the identity, again, x to the n, x to the y, that is x to the n minus y. Remember that identity. So use that particular identity there. Solve to simplify this quantity. So we'll have m over a2 squared. Just using the identity to simplify will be equal to minus p1 over v1 into 2n over 1 plus n. So we take it up, dividing this quantity by that, using that identity there, we'll simply have 2n over n minus 1 minus n plus 1 over n minus 1. And so this particular quantity now makes our life is easier now. So let's solve that expression there. So we have m over a2, therefore m over a2 squared is equals to minus p1 v1 into 2n over 1 plus n. Solving this, we have LCM as n minus 1, so that will be 2n minus n plus 1. 2n, that is 2n minus n plus 1. So this quantity here simply becomes m over a squared, a2 squared, is equals to minus p1 v1 into 2n 1 plus n into n plus 1 over n minus 1. And of course now if we remove the square root, then it is m a2 will be plus, because now if we take the square root, minus p1 v1 2n 1 plus n plus 1 over n minus 1, take the square root of that. Now, we have seen the critical pressure ratio. That is where we have the pressure at the throat and the initial pressure. And we call the pressure at the throat, we call it throat pressure or the critical pressure. So just note that for the critical pressure ratio, which we call P2 over P1, or we call it PC over P1 or PT over P1. In general, if you look at the asymptotic index of expansion, one we got in the polytropic equation, then you'll have that the isotropic index of expansion, for example, for this critical pressure ratio, when it is 1.13, that's for vapor. That's for vapor, wet vapor. We've already covered aspects of wet vapor in our earlier lectures. I continue encouraging you to again look at our lectures systematically so that you build up systematically. This will be a value of about 0.577. And when it's about 1.3, that's in the superheat region, then it might be it will be about 0.546. And even go higher, it will be about 0.528. And so clearly you can see that this critical pressure ratio is inversely related to the isotropic index of expansion. And so now we have been able to look at the pressure at the throat, and so how we got it by taking the derivative of that, the expression which we have gotten for mass flow rate per unit area and equating it to 0. And now we have seen how we can compute the value, and calculate the value, obtain the value, that's the value of mass flow per unit area. So we'll stop at that point. We are continuing with our lectures. Let's meet next time.